How to find Lagrange error. For starters, what is Lagrange error and when do we use it? Lagrange error bound is a mathematical formula used to find the maximum possible error of an estimation from a Taylor polynomial. We use Lagrange error bound because Taylor series can be infinitely long and we cannot add or subtract an infinite amount of terms to get an exact answer. We use a Taylor polynomial with a specific amount of terms to come up with an accurate estimation, then use Lagrange error bound to find the maximum difference of the estimate to the exact answer. The formula for Lagrange error bound is the error is less than or equal to m divided by n plus 1 factorial multiplied by the radius raised to n plus 1. So what does this exactly mean? The radius is the x value being evaluated minus the center. It can also be shown as the absolute value of x minus c in the formula. M is the maximum of either the absolute value of n plus 1 derivative of c or the nth plus 1 derivative of x. C is the center point and x is the endpoints or the point being evaluated. N is the degree of the polynomial to which you are evaluating it. Example 1. Find the Lagrange error bound when x minus x cubed over 3 factorial plus x to the fifth over 5 factorial is used to approximate sine of x over -1 to 1. From this problem, we already know the center is 0 and the radius will be 1. We also know we are looking for the error at the third degree, so n needs to equal 3. Let's start by filling in the pieces we already know into our formula. Now all we have left to find is m. We know that m is the maximum of either the absolute value of n plus 1 derivative of c or x, and that n plus 1 equals 4. So the fourth derivative of sine of x is also sine of x. Then we must plug in -1, 0, and 1 to find which one is the largest. The absolute value of sine of -1 and sine of 1 equals 0.841, which is larger than 0, so we'll use 0.841 as our m value. Now that we have all parts of our formula, we can do the math and we'll find that the error is equal or less than to 0.035. Here's a second example to try. Find the Lagrange error bound when p of second of x centered at x equals 4 is used to approximate f of x equals x raised to 2/3 when x equals 3.75. Let's start with what we know. We are given the center equals 4 and x equals 3.75. So we know the radius will be the absolute value of 3.75 minus 4. We also know that we're using the second degree polynomial, so n will equal 2. If we fill in our formula with what we know, all we have left is to find m. We know that m needs to be the third derivative of f of x because we are finding the error at the second degree. If we take f of x and find the third derivative, we get 8 over 27x raised to -7/3. If we plug in 4, because that's our center, and 3.75 because that's our endpoint, we find that the third derivative of f of x of 4 is 0.0116, and the third derivative of 3.75 is 0.0135. Since 0.0135 is larger, we'll plug that in for our m value, and we can do the math and find that the error is less than or equal to 0.0000353. Thank you for watching this video. We hope it helped.